Hello everyone, welcome back to this new video. So in this video we will going to learn about Rust. So I have a plan to cover all the Rust features. So I will going to start from the core functionality. If you are completely beginners about a Rust, so this is a very good start for you. So why there is another video on a Rust? If we see, there is a lots of playlist also exist on the Rust. So basically I will going to cover not only what it is mentioned in the Rust programming language. So if you are not aware about Rust programming language, so basically there is a book. The name of that book is the Rust programming language, which is hosted on a Rust website. So I really encourage you to look into that website. So basically I will going to look the Rust from the perspective of functional programmings also. So I have some experience on a Haskells and OCaml also. So I will going to see from ABC from a functional point of view how does how Rust will going to support all those functional programmings. So I have some experience on Scala, Java and C Sharp. So my most of experience on Java and Scala. So I will going to also explain from the Scala. If you know that Scala is also a very good functional programming language, but on the nature Scala is uh, OOPS based, because the JVM is by nature is the OOPS, but Scala has a very good support of functional programming, all the concepts. And if you are aware about the cats library, cat effects, these are the very wonderful library. So I will going to map all those information for the Rust also. So I really encourage you, if you even know about the Rust, so please follow this video, and definitely I will going to promise you will going to learn something new when I will come on when I will going to explain like a pattern matchings and also the ADT, algebraic data type. So at that time I will going to show some code ways or from Haskell side also for the comparisons. So that will going to increase your understanding for the functional programming also. So now let's start. So for installing the Rust compiler, so I will really encourage you to follow this link. So you can just type on the browsers like a Rust, install Rust language. So you can follow that Rust programming language book. So once you have the Rust compiler is installed, so after that you can just type Rustc hyphen version. So it will going to display you all the versions. So now let's create a new Rust program. So in this program I will going to create a main.rs. So if you don't know, the rs is the extension for the Rust. So basically like when we create a Rust program, so we have to create a main program also. So just for some time just forget about the library. So when we start the Rust applications, Rust binary, it will always going to look for the main program. It's a very similar to like a Java we have and Scala we have. In most of the language is the same type of a concept. We always have an entry point from the main. So how to define a main function? So fn is stand for the defining the function. Like in Scala we have def, and Java we have a very long structures, so you all know that. So here it's very easy, fn, and after that we can define the name of functions, and this is all. So this is how we can define the main. It will not going to accept any environment variables and any arguments, sorry, not environment, any arguments. So it will going to very simple. So let's print something. Every language is incomplete if we don't print hello world. No matter how experienced you are and how many years you have worked on programming fields, so always whenever you will go into new language you have to print hello world. I'm just kidding. Okay, so now let's start. So how we will going to run this file? So basically we have a Rustc compiler, so we need to call Rustc compiler, and here we need to pass our class name, file name main.rs. So when I hit enter, so it will going to create the binary main. So after creating this I can execute the same, and this binary will going to contain everything inside it. It's a very executable file, you don't need anything. So basically you can just give this to any persons and they can directly execute it, and they don't need to install Rust and anything. So if you remember in Java, when we package like a jars or everything, so whoever will going to execute that jar, they have to install JVMs, right? But this is not the case here. You can just directly provide this main and it will going to be run. So for running this is how we can run. So it will going to print hello world. So this is just for the example. If you see like a Rust language book, this is the similar type of example they will going to show. So now this is how we can compile. So when you install the Rust, so it will also going to have a cargo. So what is like a cargo? Cargo is like a package manager for the Rust. With the help of a cargo, we can maintain the huge package like a dependencies and everything for building and running and checking everything, like a file formatting, everything we can do that. So cargo is the recommended way for the Rust, and this is all I just show you to the basics, like we start like a Java. So now let's delete this. Yeah. So in a cargo, so if we see like cargo hyphen hyphen help, so if you see there is a lot of commands we have. So in a cargo we have a commands new. With the help of a new we can create a new package. So let's see what this has. So let's clear it, and cargo new, and after that we need to define our package name. So here we can define like a basic, or you are free to do anything, choose any other name also. So now let's close it. So inside the basic, if you see that, okay, so inside the basic, if you see we have a cargo tom file. So in this file, if you see, this is about our applications, like name of our application, version, edition, whatever it is. Like you are free to edit, free to allow to edit all these informations, and inside this dependency we will going to define our dependency here. So moving forward, I will show you how to add the new dependencies and everything. And inside src file, if you see like we have only main.rs file. So it is a very similar, previously I just show you. So this will going to be the entry point for our application. So now for running this, we have a cargo run commands. So I need to run cargo. So here it is saying, okay, could not find. Okay, first we need to navigate our folder. Inside our folder, yes. So now we have a cargo run command, and also we have a cargo build command. So build command is like creating executables binary. So it will going to install dependencies and everything, and also when I will going to run this, it will going to create a cargo log file also. So now let's run it. So now if you see we have a cargo log file. So what is it log file? So basically, like if you see when we do like a development, so we will going to have a lot of dependencies, right? So we have a particular version for all those dependency. So in the future those dependency will going to be changed if we don't log those binaries files, like all the peers dependencies and everything. So in future when we going to install all those dependency, there will not be any guarantee. We will going to have the exact environment variable at that time we build, when at that time we added all those dependency and we able to run our application. So this cargo log file will going to give us the guarantee all the definition, all the versions we have mentioned in this cargo, the same version I will going to have if I install all those dependency even after 1 year, if those dependency exist in basically in repository. Yeah. So you can just map this node.js package log file also. Like in node.js we have a package log file, even in front end also we have log file. So you can just map with this. If you are still confused, so when I will going to install those dependency, I will going to show what this log file will going to be contain. So inside the target we will going to have here this basic file. It will going to be a executable file. So if I run this like slash, target, and inside target we have debug, sorry, debug, and inside the debug we have a basic. So if I execute it, so if you see, it will going to print the hello world. It is very similar. Previously I just show you like creating a main.rs file. So this is where you can also do that, but it is, I'm just showing you this is the same things which we previously did. So now for running this projects in cargo, we have a command cargo run. Let's run this, and it will going to print everything whatever we have in our application. So I hope it's clear for you. So now let's move further. Okay, let's start with variables, how to declare the variables and what type of data type we have. So after that we will going to see how to create a function. So let's start. We have a let winding here. It's very equals to like in a Haskell we have a let, also in a TypeScript also we have, but Haskell has a different meaning also for the let winding. So now let's see, with the help of a let, you can just assume if you are completely new, we can create a variable, and what will be the type of this variable that can be defined whatever data we will going to assign here. For example, if I assign like a 5, so now you will going to notice, so it will going to display like a I32. So what is I32? So basically you can just see it will going to be like a integers in 32-bit. So I will going to explain all the data types later point of a time. So you can just imagine this is integers, okay, and after that I can define even I can specifically type the name, sorry, age. Specifically I can also write a type here like this. If I want to define like this string, and if I define something like that, okay, it will going to give me the error. So you were maybe like you are surprised why it is like that, like a, in a double quotes whatever we are defining, it is not the string. So here we have a different concept in a Haskell, like a, we have string literals and string, those are like a totally different. So here if you want to have a string, so this string will going to be allocated on the heap, and it will be like a mutable also. So I can create a string something like that, colon colon, and we have from, and here I can pass the string literal. Okay, so this is the string literal. So by using this, it will going to create a new string instance, and that will going to allocate it on the heap, and this string is containing the pointer. I will going to explain that thing is in detail. So if it is confusing and if you are wondering what is it, I will going to explain these things also. So this is nothing, it is just the string. So for this string, if you see like is a struct type, and we will going to have some functions also. So if we go inside the implementation, so we have so many implementations. So let's look for a new, it's very hard to find out. Okay, let's search from, yeah, here. So now you can see like a, we have a from, and it is receiving a strings, and this is how, if you see, this is for the string literal, we are passing string literal, it will going to convert to the string. We will going to see this thing impls, what is extract and all this thing. If you are, if you know C, then you must be aware about it, what is extract data type. Okay, so this is how you can define. So what about mutability and immutability? So basically by the nature, rust will going to favor immutability. So every variable here I have defined, everything is immutable. So for example, if I try to reassign any variable later point of a time, so it will not going to allow me, it will going to throw me the error. Here you can read it, cannot mutate immutable variable. So by nature every variable is immutable. So if I want to make this mutable, I have another keyword mut. So if I add this keyword, so after that I am allowed to change. So this is how we can have a mutable variable and also immutable variable. So by default every variable will going to be immutables. in a Rust, like a let, we have another keyword also cons. So here you can define another variable. So here you need to define a data type for this, and here you can define the value. So this will going to be a const value. So even if I change, if I want to use this as a mutable, so it will not going to be allow it. So when we define any variable as a const type, so throughout the life it will going to always the constant. So Rust will not going to allow to mutate that variable. So I hope it's clear for you what is mutable variable, what is immutable variable, and how to create it. I know data type you even don't know for now what type of data type we have, what is it, like what is string literal, what is a string instance. We will going to cover all this thing, but I am assuming by now you have a clarity what is let and what is const. So now let's move forward. So we will going to see for the scope, or there is another word for also shadowing. So now let's see. So let's define another variable x equals to 5. So if I create another scope like this, so just assume this curly bracket will going to create another scope, and here if I define x again, and if I assign like a 12, okay, and if I try to print here, so what it will going to be print. So for printing any variable in a Rust, you can use this macro. So what is macro we will going to cover later. For now just assume this is some kind of a function, okay. For these functions we need to define our string. So here we can access like this any variable, okay. So now let's see what we will going to have. So for running is very simple, cargo run, and here if you see x is 12. So in this scope we have redefined x equals to 12. So Rust will not going to create any problem. So even x variable x is already exist, and it will also going to allow if you want to redefine that x. And even if I create x here, x, let x again for 32, it will not going to create any problem. It's allowed to create the same variable with the same name and with a different value. So what will going to happen to this value, we will going to discuss these things later point of a time when we comes to on the concept of ownership and borrowings and slicing at that time. So now I hope clear for you. So from these two things we have learned, this is how we can create the variable, and the same variable with the same name we can declare again. It will not going to create any problem. And this is how if we have another scope, within that scope it will going to look for a near variable. If we declare that variable again, so this value like a x will going to shadow all the x value which we have created in outer scope. So here if I see, if I try to print here again x, so now let's see. Okay, so it is in outer scope. So now let's run it. So now if you see we have a x32. So this is the value we will going to have here. So this value is like shadows completely in even in a inner scope, even in a outer scopes also. So now I hope from this you have a clarity about the scoping. So it's a very easy concept. There is no fast and no like a special thing Rust has did. It's a very similar to our Java. I hope it's very clear too, but this is something new. In the same scope we can redefine the same variable like this, but when we going to redefine the variable, we have to define completely with the let winding. We cannot do like this, okay. If I want to do like this, it will not going to allow. I have to declare this variable as a mutable variable. After that I can do this. I hope it's clear for you. Let's move to next concept. So we will going to see all the data type. So now let's start with the integer. So what is integer data type, and what type of data type we have available for integer? So in a Rust we have a concept for signed and unsigned data type also. This is also exist in other languages also, but Rust has very interesting. So we have a integers. We can define a signed or unsigned type of an integer with a 8 weight, 16 weight, 32 weight. So for example, if I want to define a 8 weight integer, okay, so I need to define like I8. and here I can define like a 1. Okay, so how it will going to be work? So it is a 8-bit integer. Okay, and it is a sign because I stand for the sign, and if I want to define integer unsigned, okay, so I have a u stand for that. So what is the difference between these two? So basically we start with the signed integer, so there is a formula, so how many number you can represent with by using a 8-bit. So for the signed it will going to contain negative values also. So if I see like here I can have a like 1 minus 12, and here if I try to have a minus, it will not going to allow. It will going to complain here like unsigned variable cannot contain a signed value. So now let's see the range for this 8-bit, and it will going to hold true for every type of a data type like 8-bit, 16-bit, 32-bit, and moving forward to 128-bit. So there is like a formula. So for the signed it will going to be like this, minus, and from 2 key power n minus 1, like this, uh, to 2 key powers n minus 1, like this. So this much numbers we can represent. So if we calculate for this 8-bit, so it will going to be like this, minus 2 key power 7 to 2 key power 7. This much numbers we can represent if we decided to use the signed bit. Let me reconfirm. Okay, so I just checked, minus 1 is also like a last digit is not inclusive. Okay, so this will going to be the range. So when it's come to the signed variable, so for the signed variable it cannot contain the negative value, so it start from 0 to 2 key power n, 2 key power n minus 1, and this minus 1 is not from the n. Okay, something like that. Okay, so here you can see if we use the signed variable, this will be the range, and if we use the unsigned variable, this will be the range. So basically number of a element, if we see, both will going to represent equally, it just differ by the range. So in a similar way like a I8 we have, so in a similar way we will have I8 and also like a I16 and I32 and I64 and I128, and in a similar way you will going to have corresponding to every data type uh, unsigned type also, something like this. I hope it's clear for you. It is not that much difficult. Definitely, if you are new, it will go into something new because we never used to define something like that in a bit like I8, I16, something like that. Okay. By default, Rust will going to use I32 if you don't define something, if you don't define any data type. So what I am saying, if you try to define something like this, so Rust will going to assign this I32 by default. So now let's move for the float type. So we have a float type. For the float type, concept is very similar. So we can have a float like this. So let's define a variable I float, and for the float we have a f32, something like that, and I can define like this something. So it will going to use a 32-bit for representing this float number. If I don't define data type explicitly, so by default it will going to use 64-bit. So it's a very similar to like integers we have defined. So now let's move to the next data type. In a similar way we have a boolean data type. So let's define a boolean. So if I define like this is very simple. So it will going to have a data type like a bool. And in a similar way we have a char data type. So this is how we can define a char. So I hope it's clear for you for the data type. And now let's move for the tuple type. So we can define a tuple also. In Java there is no tuple, but in I think in C Sharp, in Scala we have a tuple. I am sure for the Scala, but I am not sure for the C Sharp. So for defining a tuple is very simple. So this is how you can define a tuple. So here if you see, I created a tuple. So first number is integer, so it will going to take the default data type for the integer, which is I32, and this is float numbers, and default for the float is F64. This is how you can define the tuple, and this is like this. Okay. And even in Rust, it's follow a destructuring, or you can say like a pattern matchings also. We can do pattern matchings over this tuple also, something like this, let winding, and here I will define a tuple, and I can destructures all the data of tuples. So I can define like a age, uh, rate, name, something like that, and it will going to define automatically type of these variables. So I can like a pattern match over this tuple like this. And in JavaScript, this concept is known as like a destructuring. And in functional programming, if you see, if you aware about the Haskells and OCamls, we call this as a pattern matching, like doing the pattern match. Okay, so now let's move further. So similar to this tuple, we have on this tuple we will going to do something more moving forward. So but it is a very basic. This is how you can define the tuple. And in a similar way, if you want to define an array, so this is how we can define an array. And now let's see. So I just declare the array, something like that. And if you see, it is pick auto data type. So if we see here, it is saying I32. Okay, we know that I32, it is basically saying this array is containing a signed integer 32-bit, and after comma, after comma we have a 5. So 5 is basically the size of this array. So if I define something like that, it will going to be 6. Specifically, I can write like this: I64, I want 64-bit, and I want 10 length. Okay, okay, it's not comma, it's semicolon. Yeah, so here it will going to say I have to have 10 numbers in this array. I cannot have like this 7, 8, 9, and 10. Now it will going to be happy. So this is how we define array. If you are wondering how we can have a array, how we can have a array without the size, so there is a collections also we will going to be cover. And later point of a time I will going to show also, like in a function, if we are defining the array, do we need to define the size or not? So I will going to explain this thing. Yeah, this is all. Yeah, one more concept also, like if you are wondering how we will going to access the array, the concept is very similar like in other languages. This is how you can access the value of array, like 1, something like that. Okay, here it didn't allow, I don't know like why. So you need to define like this, and now you can print this value. Okay, so this is how we can access the any index value of array, and this is how we can print. It's very straightforward and very similar to other languages also. So if you are just watching this video and if you are not following, I really encourage you to please follow with me, otherwise you will going to forget. So the more you write, the more you able to grasp the concept. So now let's clean this all. So we will going to learn now about a function, what is function and how to define the function. Okay, so now let's start with the function. So how to define the function? So it's very simple. So we have a fn keyword in a Rust for defining the function, and after that we need to define the name of this function, like get name, and this function will going to return the name. And what will be the return type of this function? Okay, so let's have something like that. Okay, so instead of let's start with a simple definition. Say hello. So whoever will going to call this function, it will going to print hello world. Very simple. Okay, and now we can call this function inside our main, something like that. So now if I run this program, so it will going to be print hello world. Okay, so if we want to have like another function like a greet, and here we wants to pass something name like this, and we wants to greet with this person. Okay, so how we can define something like that, like a fn, we can have like a greet, and this function will going to receive some argument. So we need to define a function which is parameterized. So here we need to define like a name. And what is this? So you already know that this is a string literal. So for string literal, we need to define something like this string. Okay, and after that open the body, and here we can print ln and something like this hello, and here we can have name, something like that. Okay, and just comment it out and now run. So it will going to be print like say hello Vikash. Okay, so this is how we are receiving a string literal. If you want to pass like a string, then you can have something like that string. And here it will going to be complaint, because we need to convert this literal to the string instance type. So we can have string, something like that. If you are wondering what is literal, what is string, I will cover in detail, but for now you can just assume this is mutables, and when we have a string literal which is immutables, and string instance got created on heap. So now let's run this. It will going to be work as expected. So now let's define another function, something like that. If I want to have some function get name, this functions will going to read a name, and it will going to return me a type of string, something like that. So how we can have some functions which return something for us. Okay, so let's define this function. So for return type, this is how you need to define the return type. After arrow, after the when you close this parenthesis, after that you need to open the arrow, and here you can define the return type and open the body. So in this body you can just return the value. So how we will going to return the value? So now let's define name, and let's create some string. Okay, some string. So if I write this string like this, so whatever is the last value, if it is matched with the string, it will going to be returned. Okay, the concept is very similar. So in a Scala, it's a very similar we have. And if just suppose if this name is integer type and we are expecting to the string, it will going to give me the error. So the last variable has to be the type of this string. So now let's print this, and now let's run, and now here you can see it's returned some string. So it's very easy. So this is how we can define the function. This is how we can accept the values in functions and also return from the function. It's very easy. So now let's move to the next one more concept also, like similar to this. So just assume if we have let a. Okay, I want to define this a some values, and if I want to do some calculation, so I can open curly brackets like this, and here I can do some calculation. For example, let x equals to 10 into 20, very complex calculation we are doing, and after that we return the x. Okay, so whatever we have returned from here, right? So Rust compiler will going to infer the type of this variable. So what will be the return type of this scope? So what will be the return type like? So it will going to be identify return type whatever we have in the last expression. So similar to the function, we have a scope, whatever the last expressions, and what will be the type of that expression. If that expression is evaluated, if it is integer, if it is string, the value of will going to be the same value it will going to be returned. Okay, so here this x is integer, so it will going to infer the type, so a must be the integer type if a wants to take the return value of this scope. Okay, so for example, from here if I define like something like this. Okay, so now let's do one thing, remove this. So now if you see the type of this a, now it's a literal type of string. Okay, it's a string literal, sorry. So because I am returning the literal from the last expression, if you see for this scope, it's a very interesting, but I'm not sure how useful is it. So now let's move to the next concept. So now let's understand what is if else. So for example, I have a condition where I'm saying if x, sorry, if 10 greater than 2, so it will going to have a boolean type. So based on this, if I want to have some condition, if condition, if it is true, I want to print it works, and if it is not evaluated to true, if I want to print exit, something like that. Okay, so this is how you can define if and else. So it's very simple and then very familiar to other languages also. So like there is nothing much to explain about this if and else, so you can just relate your knowledge with the existing languages also. So now let's move to the next concept. I will not going to spend much time on trivial concept. There is a loop also in a Rust, so I will going to cover that thing is a later, because that is not like a good practice for using. So okay, let's see that also. If you are wondering what is loop, so you can just this is how you can have a loop, and this body will going to be evaluated in a infinite times. So if you want to exit from this loop, like if I print like working. Okay, so now let's have some variable let and counter equals to 0, and we will going to have a table, and inside this I will going to have a condition if counter is if less than 5, sorry, if counter is greater than 5, then break. Okay, so this is how we can break this loop. So now let's run this and let's see. Oh, so I forgot to increase the counter every time. So counter equals to counter plus 1. Okay, simple. And now let's run this. So now if you see, it will going to print working, and after that it will going to be exit. So this is not the like good practice in my knowledge to using something like that, but it's worth to know like we have something like that. So I'm just hoping now you know this concept and just forget about it. No need to use this thing.